Okay, so in this example, we have two skaters standing still in the center of an ice rink, and one has mass 50 kilograms and one has mass 100 kilograms. So one is twice as big as the other. And we're saying that the heavier skater is going to push off the lighter one. So first I'm going to point out the ice rink. So you might notice as the semester goes on that we have a fair number of physics problems that take place on ice rinks. And the reason for that is the ice rink is sort of our classic frictionless environment, right? So if we want to make it seem reasonable that in a certain problem we don't have any friction, then we might say it happens on an ice rink. Okay, so the heavier skater pushes off the lighter one, and for the first question we want to know, how do the forces on the two skaters compare? So if you want to think about this for a minute before I start talking, then now would be a good time to pause it. Okay, so the key here is that this is 100% a Newton's third law problem. And so Newton's third law is the one that says for every force there's an equal and opposite force. So that means if the heavier skater pushes on the lighter skater with a certain force F, then there must be a force exerted by the lighter skater back on the heavier skater that's the same magnitude but opposite direction. So we would say, how do the forces on the two skaters compare? Equal magnitude, opposite direction. Okay. Okay, so that's part A. So for part E, or part B, how do the accelerations of the two skaters compare? Okay, so if the forces are the same and F equals ma, then the acceleration of each skater is just F over m. And so if the forces are the same but the masses are different, then the accelerations must also be different. So the acceleration of the 100 kilogram skater has to equal the force over 100 kilograms, and the acceleration of the 50 kilogram skater equals the force over 50 kilograms. Now we have no idea what that force is. It may not even be the same over time, but the two forces on the two different skaters have to be exactly the same. And so that means that we know now that the accelerations have to differ by a factor of 2. So we can say the acceleration of the heavier skater is just half that of the lighter skater. And that makes sense because it's easier to accelerate a lighter object than a heavier object. Okay. So now for part C, how do the final speeds of the two skaters compare? So we know the speed is going to be equal to v naught plus at, but we're saying they start at rest, so v naught is 0, so v is just equal to at. So that means if the acceleration of one is half as large as the acceleration of the other, then the velocity of the one is just going to be half that, the final velocity of the other. So the velocity of the 100 kilogram skater is just going to be half that of the 50 kilogram skater. And again, the reasoning for that is just the velocity is v equals at.